right, so what we're going to be doing today is, first of all, 9.2, and it's called the inverse functions. Okay, when you're finding the inverse of something, it just means you're going to flip their x and their y. You're going to put the x in the y spot and the y in the x spot. So if you are looking at a problem like number 1, it's literally just going to give you 4 points and ask you to find the inverse of the relation. Okay, so if my points are at -9, 5, -7, -1, -5, -3, and 5, -5. And it wants me to write the inverse of this relation. All that means you're going to do is rewrite all these points with their x and y in the opposite spot. Okay, so this one is going to turn into 5, -9. Now, Math Lab is also going to say to put a comma in between your points. Then -1, -7, comma, -3, -5, comma, and -5, +5. So all you're doing on a problem like number 1 is just rewriting the x and the y in the opposite spots. Okay, same kind of thing's going to happen on number 2. But instead of giving you points, it's going to give you an equation and ask you to find the inverse relation. So x to the 3rd y equals -5. If I'm finding the inverse of this, that just means switch its x and y. So it's going to be y to the 3rd x equals -5. Now I'm going to work numbers 3, 4, 5, and 6 all together. But what it's going to ask you is this relation 1-to-1, or is this function 1-to-1? What we're going to use for that okay, a function is 1-to-1 if any, this time, horizontal line. Remember the vertical line test that told us if the relation was a function at all? What did the vertical line test say? If you draw a vertical line and only touch it once, then it's a function. Here, if you want to know if the function is what's called 1-to-1, any horizontal line can be drawn through the function and only touch it once, then it is 1-to-1. Okay, 1-to-1 functions are the type of functions that can have inverses. Okay, so the problems at the end of this section, the first thing it's always going to ask you is whether or not the function is 1-to-1. So you'll answer yes or no. If the answer is yes, then you're going to find the inverse of that function. Okay, so 3, 4, 5, and 6 are all graphs, and all it's going to ask you is whether or not it's 1-to-1. So on number 3, it makes no difference where I draw a horizontal line. How many times am I going to touch this? That's an exponential function. Only once, right? Doesn't matter where you put that horizontal line. It's only going to touch the graph or the function once. So yes, that one is 1-to-1. But what about this one? How many times are you going to touch it here? Twice, which means it is not 1-to-1. This one, there, twice, there's twice, no. Now this one, it's hard to tell from my drawing, but this is not going horizontal. It's kind of going slightly down, then it does a squiggle here, and then this side is going slightly up. It's not horizontal in any area, okay? It'll be more recognizable on your graph, but so it doesn't matter where I draw a horizontal line, it's still only going to touch that graph one time. So yes, this one is 1-to-1. Now, for the rest of this section, it's not going to give you the picture of the graph. It's just going to give you what the function is written out in like y equals or f of x equals, and you're going to have to find the inverse of it. And here are the steps. Okay, the first step is you're going to replace, these are all going to come in saying f of x equals whatever. Now remember, f of x and y mean the same thing, right? So I can replace f of x with y anytime I want. It's the same exact thing. Because the reason you wanted to say y equals instead of f of x equals is because the second step is to, like we were doing in problem number 1 and 2, I guess I should say invert or flip out or replace. So you're going to invert x and y, just like we did in problems 1 and 2. Wherever I saw x, I put y, and wherever I saw y, I put x, which in turn is going to put my y in a new spot, right? It's going to put it where the x was. The last step is to solve for y in its new spot. Get the y by itself. The answer your original equation is going to have f of x. This little -1 that you're going to see in the answer boxes, that means that -1 means that's the inverse of the original function. So f to the -1 of x means the inverse of f of x. Yeah, f of x is going to be your original function. All right, so number 7, you have f of x equals x plus 8. F of x equals x plus 8. Yeah, this is like number 7. So we're going to follow the steps to finding the inverse of one-to-one functions. First of all, it's going to ask you, is this function 1-to-1? If x is just an x, what kind of shape is this going to be? It's just a line. all lines, unless they are horizontal, are always 1-to-1. They're all going to be able to pass the horizontal line test. So yes, this is 1-to-1. So now we can find the inverse of this. The first step is to change this verbiage to a y, right? F of x and y mean the same thing. So I haven't actually done any inverting yet, right? I just changed that to y. The second step is to invert the x and the y. So now I'm going to have x equals y plus 8. Now your y is in a new spot, and that's the y you're going to want to get by itself. So I'm just going to subtract the 8 from both sides. So now I have x minus 8 equals y. This is the inverse of that. Yeah, it's actually in Math Lab, it'll have this. So it's got this part there for you. So all you're typing in is x minus 8. Right, number 8, f of x equals 4x minus 6. So again, they're all gonna, I'll just give you a little hint. They're all gonna be 1-to-1. Well, except one, but it'll still be workable. Yeah. All of it. Wait. Hang on. I don't know. I'm not 100% sure I understood yet. The only thing you're inversing is the x and the y. So what do I do first? I change this to y. The only thing that's changing when you invert, right? So this is going to turn to x equals 4y. Yeah. So now I'm solving for my new y. Get rid of minus 6 plus 6. So now on the left, I've got x plus 6 equals 4y. And then divide both sides by that 4 to get that y by itself. So those 4's cancel. There's y by itself. It'll actually on this one let you just leave that fraction like that. So x plus 6 over 4 is the inverse of 4x minus 6. All right, number 9, same type of thing. It's going to be a little more difficult to get the new y by itself. F of x equals 3 over x plus 9. Okay, it is going to be 1-to-1. So the next thing I'm going to want to do, what does f of x really need to be called? Y equals 3 over x plus 9. Now you're going to invert. So what's this going to look like now? X equals 3 over y plus 9. Good. Now, here's the tricky part is what are you solving for? What do you want by itself? That y. anytime the variable that you're solving for is in the denominator of a fraction, it can't be isolated while it's in the denominator. Okay, which means whatever that denominator is, multiply both sides by that, because what that's going to do over here is what? Cancel that. If I do it here, I have to do it on this side also, right? But look, if I multiply y plus 9 times x, I'm just distributing here. The y is not going to be in the denominator anymore. So let's see, the y plus 9s cancel here. So I've just got that 3. On the left, I do have to distribute, multiplying y and plus 9 times x. So it just distributes. So x times y is xy, x times positive 9 is positive 9x. So that step just simply helped me put my y in a position to where now I can isolate it, right? It took it out of the denominator. So the first thing I want to do is get rid of that plus 9x. How do you get rid of plus 9x? Right. Okay, now I'm going to take it up here so y'all can see better. What's left on the left side? Just xy. On the right side equals 3 minus 9x. So I'm almost got the y by itself. The only thing that needs to go away now is that x that's hooked onto it. What do you do with, what does that mean? It's saying x times y, which means how do you get rid of times? What's the opposite of it? Divide by. Good. Right, divide. What do you want? You want to get rid of the x, right? So that's the one you're dividing by. Now, on this one, when I do it to the other side, I'm actually going to divide both the whole thing by x. So I could have put this as just having an x in the denominator, but the reason I put it under both of them, it means the same thing. This and this mean the same thing. All the terms in your numerator are over your denominator if this is all one big fraction. The reason I wrote it like this time is because look what's going to happen there. Yeah, so you're going to just be left with y equals 3 over x, because that can't simplify, minus the second term, the x is canceled, so I'm just left with minus 9. All right, number 10. Okay, before I get started on doing this one, every time when I'm trying to isolate the y, how do I remove stuff that's with it? Whatever it's doing, I do the opposite, right? If I need to get rid of a plus 5, I'll minus 5. If I need to get rid of x times y to get rid of that x, since what's the opposite of times? Divide. That's what cancels stuff out, okay? Let's look at this next one. Number 10, f of x equals x to the third minus 5. The first two steps are always the same. Change the f of x to the y equals x to the third minus 5. Then interchange your x and y. So x equals y to the third minus 5. Get your new y by itself. Get rid of minus 5. We know how to do that. Plus 5. So on the left, now I have x plus 5 equals y to the third. This is what we have not seen yet. So I need to get rid of that third power, right? So that y will be alone. So I need to find out what is the opposite of cubing something. Not square, but the same idea. Cube root. Whatever the power If you're trying to cancel it out, use that same root number to cancel it out. So if you cube something, the opposite of it that's going to cancel it out is cube root. Do it to both sides. So on the right, the cube root cancels out the cube. There's your y by itself. Cube root of x plus 5 on this side. Now, two things we need to talk about, because this one is multiple choice, and I want to explain why the answer is what it is. Okay. First things first is how am I gonna? Oh, I don't have to type it in. Oh yeah, I did. And just forget everything I said. So how do I type this into MATLAB? Down in your toolbox, you're going to see two different kinds of radicals. You're going to see one that looks like this with only a spot there to put your answer. And you're going to see one that looks like this right next to it that's got a spot here and here to put your answer. So if it's anything, this only works with square roots. This works with every other kind of root. If there's a number in here at all, you're going to use that so that you'll be able to type in your little 3 right there. It doesn't go out next to it. It goes in the little house. So, and then you can put your x plus 5. Okay. Yeah. Yeah, that's the answer. That's just explaining what tool you use in your toolbox to type in your answer. So that you want that little box right there to be able to type in the cube root. So, okay, I've seen this before. I can't remember, like you don't have a toolbox? Uh-huh. Because that's weird. So what are you using? What are you like? What are you using, like an iPad or a laptop or? Okay, I wonder. Let me figure out if there's something. Let me ask. Right. You just gotta do extra stuff. Let me see if I can ask if I can figure that out. All right, number 11. F of x equals 3x squared plus 2. And then you'll see next to it, comma, where x is greater than or equal to 0. The reason it has this is because if I graph this on the graph, what shape is this going to make since it's squared? The U, a parabola, right? Well, a parabola, as it's written, is not one-to-one, right? This one would look, if you put it on the graph, it would look something like this, which obviously doesn't pass the horizontal line test, right? It would touch it twice. But this little statement that's after the equation says where x is greater than or equal to 0, okay? So here's where x is 0. It just wants you to find, so these numbers, what are the x's? Less than 0. So it kind of just wants you to only look where the x's of that are 0. So you would just be taking into account this part of the parabola that does pass the horizontal line test. You see what I'm saying? That's all that this right here means. So now let's find the inverse of half of that parabola. This is a y. So y equals 3x squared plus 2. Invert your x and y. So x equals 3y squared plus 2. Solve for your new y. So get rid of plus 2 with minus 2. So x minus 2 equals 3y squared. Get rid of your 3 now by doing what? How do I get rid of 3 times? Divide. So now I have y squared equals all this, x minus 2 over 3. And then what's the opposite of squaring? Square root, good. Yep. So the square cancels out the square root. There's your y by itself. And then this whole thing is your answer. So you're going to have the square root of x minus 2 over 3. It's actually going to have all of that already typed in for you except for this. You'll just have to type in that x minus 2. All right, last one. F of x equals the square root of x plus 6. So first things first, change your f of x to the y. So y equals the square root of x plus 6. Now, interchange your x and y. So x equals the square root of y plus 6. So if I'm solving for this y, I can't subtract 6 yet because it's like it's not just plus 6 as of right now because it's under that square root. It's like it's trapped. So I got to get rid of the square root first. Remember, radicals or roots are opposites of exponents or powers. So in order to get rid of that square root, you're going to square both sides. So now I have x squared equals, those cancel, so I just have y plus 6. And subtract the 6 from both sides to get the y by itself. So on the left, I have x squared minus 6 equals y. So there's your inverse. Now this one is multiple choice. I don't have to type anything in, but you'll notice it'll have this. One of the options is this comma where x is greater than or equal to 0. Okay, the reason is what kind of shape is this going to end up being? Parabola, which is not 1-to-1. So, but this, if I put both of these on the graph, let's see, this one, the square root of x plus 6, square roots. Look like that, finding the inverse of it, which is x squared minus 6. But inverses, how they relate to each other is if you drew a line through this origin, a diagonal line like this, inverses, and if you folded it on that line, inverses would lie on top of each other. That's why this statement is here. On this parabola, it only wants to use the part of it where the x's are positive, which is this part of it. So it wants us to just ignore where the x's are negative. Now, those are inverses of each other because if you folded it on that green line, they would lie on top of each other. Okay? All right, go ahead. Yes, and this is a multiple choice option, but again, it's saying you only want to use this part of this right here. If you put it on the graph, it's going to have that part, right? It is a parabola, but only this part of the parabola is the inverse of that. This makes it not, right? This goes. Because if, I mean, just because if you did use where the x's were negative, it wouldn't be the inverse. If you folded it on the green line and you still had this right here, this and this are not going to lie on top of each other. Only this is only going to lie on top of this part of the parabola, not that one.
So they are supposed to lie on top of each other.
Yes, if you're an inverse of another function, this always is going to happen. That line right there, if you draw a line right there and fold it on that line, inverses of each other will lie on top of each other. That's why you don't need to use that side. So that's what this statement means. Only the part of the parabola where the x's are greater than 0, which just means positive. Okay. Oh, that's kind of confusing. I'll try to think more on a better way to say that. Okay, we are going to start 3.5, and then we'll finish 3.5 on Wednesday along with 3.6, because 3.5 and 3.6 go. Okay. Okay. What 3.5 is called solving systems of equations. And it's called in 3 variables, but all we're going to do today, just to warm us up, is solve systems of equations in 2 variables, which means we're going to be given 2 equations. Each of the equations are going to have x and y. So we're going to find the x and the y that satisfies both equations. Okay, so again, you're going to have an equation that has an x and a y and another equation that has an x and a y. What you're actually finding when you're solving a systems of equation, which is on like number 1, you have 6x plus 3y equals negative 45. And 8x minus 3y equals negative 81. So there is an x and a y that makes both of these situations true. If you replace the x and the y with certain numbers, it works in both. What you're doing when you're solving a systems of equations like this, if you got y by itself in both of these and then graphed them, x would just be x, so they're going to make lines, right? They're going to make 2 lines. The x and the y that you find is actually the point where those 2 lines would intersect, right? Because if the x is the same for both of them and the y is the same for both of them, they're going to have one point that's on both lines, which would be the point where they would intersect. So to find that point, we're going to use what's called the elimination method. My goal is to be able to add the equations straight down, add them to each other, and eliminate either the x's or the y's, which means you want your x's to be the opposite of each other or your y's. Did you have a question?
Oh, no. Can you answer it?
Oh, yeah, go ahead. What is it?
-9
Yeah. Did you just do that in your head?
Yeah.
You're smarter than I am. If I add these together, what's my x is going to be? 14. What happens to the y's? They do eliminate each other. That's how you really want it to be set up, because if that's the case, then you just go ahead and add the equations together. 6 and 8 gives me 14x. The y's do eliminate each other, equals negative 126. So if you eliminate your y, look at your equation now. It just has an x in it, which means you can solve it for x. By doing what? Dividing by 14. So x equals negative 126 divided by 14, which I guess is negative 9. So negative 9 is the x coordinate of where those two lines would cross. So if I know what the x is, what can I do with it? Plug it in, put it in the x spot. You can use either one of these. It works in both of them. If you put a -9 in either one of those spots, the y is going to end up being the same. So just to be uniform and to do the same thing all the time, I usually just go all the way back up to the top equation. So I have 6, put in -9. So 6 times -9 plus 3y equals -45. So now the only unknown I have is the y. So I'm going to solve for it. 6 times -9 is -54. Plus 3y equals -45. Solving for y, so get rid of the -54 with a +54. So 3y equals -45 plus 54 gives me 9. And divide by 3. So what does the y equal? 9/3, which is 3. So that is the answer to the systems of equations. Okay. When you type it in, the solution is this ordered pair is how it wants to be typed in, not just -9, 3, but when you put -9, 3 in an ordered pair, that's telling it the point where they intersect. So you want to enter it as an ordered pair. Okay, but what about like number 2? (5x plus 3y equals -11). And 3x minus y equals -1. Okay. What I noticed first is, remember the last one, my y's were the opposite of each other. So when I added them together, they canceled each other out. That is not the case here though, right? This would give me 8x, this would give me 2y, nothing eliminates if you add them together. But remember the rules of equations. I can do absolutely anything I want as long as I do what? Both sides. Yeah, you can do anything you want to an equation as long as you do it to both sides.
So you just multiply by 3.
Because what happens if I multiply this one times 3, this whole equation, what does it turn this into? -3, which will eliminate the +3. So that's what you want to do. You just, and it doesn't matter, you just need to make either the x's opposite of each other or the y's opposite of each other. Not yet, because if you combine them, you haven't helped yourself because you still have an x and a y. You want to have an x or a y.
Okay, so it's 9x minus 2y equals -3.
Right, because so if let's say I wanted to, I'm choosing this one. Because this one, all I have to do is multiply that whole equation times 3, because it'll make the y -3. Don't write this down. If I chose to eliminate the x's, I would actually have to mess with both equations, right? I can turn this into a -3 just by using a 3. But if I was going to eliminate my x's, I would actually have to mess with both of them and make one of them. What's the first thing I can turn 3 and 5 into? 15, which means you'd want to make them opposite 15s, which means if you make this one +15, you'd multiply it times 3, which means this one would need to be -15, so you'd have to multiply it by -5. But if you can only mess with one equation, then just do that. To make this a -3, I'll just multiply it by +3. So what's it going to turn this whole equation into? 9x minus 3y equals -3. So these two equations are still about equal to each other because I did the same thing to both sides. But now I can add this equation to this one and eliminate my y's. So how much x do I have? 14. My y's cancel, equals, right, negative 11 minus 3 or negative 11 plus negative 3 is negative 14. And divide by 14. So what does x equal? Right, negative 1. So there's your x. Now, just like always, go find your y by replacing this x with negative 1. So I'll have 5 negative times negative 1
I don't know.
plus, and I've already worked this today, 3y equals negative 11. So all I've done is replace the x with negative 1. 5 times negative 1 is negative 5 plus 3y equals negative 11. So if I add the 5 to both sides, so what am I left with on the left? 3y equals negative 11 plus 5 is negative 6. Divide both sides by 3. Good. Y equals negative 2. All right, last one that we're going to do today, number 3. Yeah, systems of equations. 3.5. Oops. Okay, so I have 6x minus 9y equals 7.5. And then the second equation has 7y minus 2x equals negative 4.5. So the first thing I notice is that my x's and y's aren't lining up. So on this second equation, I just need to flip-flop those, right? So that my x's line up with my x's and my y's line up with my y's. Okay, so I'm just putting the negative 2x in front. Then the plus 7y equals negative 4.5. So once I do that, I don't even need to see this equation anymore, right? Because this one's the same thing. It's just written where my x's and y's line up. So look at your x's and your y's. Adding them together won't eliminate anything. Can you turn, what do you need in order to knock out a positive 6?
Multiply the second one times 3.
Right, because what's the opposite of that? Negative 6, which means, can I turn this by multiplication into negative 6? Yeah. What kind of? Nope. What's? Yeah. You got yourself. So I'm multiplying both sides by positive 3 in order to turn my x's into negative 6. So let's see. 3 times negative 2 gives me negative 6x. Plus 3 times 7 is 21y equals, is that right?
Yes.
Negative 13.5. So now add these two together because your x's this time will cancel out. Doesn't matter, just one of them has to cancel out. So negative 9 plus 21 gives me what? Positive 12. Equals 7.5 minus 13.5 gives me negative 6. So what are you dividing by? 12.
Yes, ma'am.
So what does y equal? Negative 6 divided by 12. Since the question started with decimals, it'll let you use decimals in your answer because what do you get when you type in your calculator? Negative 6 divided by 12.
Negative 0.5.
Negative 0.5. So you can use that. And where does this go? Who is this? That's the y. Yeah, so it goes in the back. So when I go up to my original, I'm putting negative 0.5 in this spot. So I have 6x minus 9 times negative 0.5 equals 7.5. So it's negative times negative, so it'll be positive.
4 point.
Plus 4.5 equals 7.5. So I'm getting x by itself. So get rid of plus 4.5 with minus
3.
4.5. So now I have 6x equals 7.5 minus 4.5 is 3. And divide by 6. So x equals, when you do, right, 3 divided by 6, it gives you positive 0.5, which is your x. We will wrap that one up on Wednesday.